All right, 8.2a, power functions. So we are performing operations with power functions and then focusing on finding the domain of those power functions. So move this, a little bit more space. Okay, so here's a couple power functions, and we're going to practice simplifying these. Now these are just like polynomial linear functions. So just like you're used to, 2x plus x plus 1. Well, here it's just 2x plus x plus 1. There's nothing in front of the parenthesis. Then combine like terms, 2x plus x. They're the same thing, so combine the coefficients, you get 3x plus 1. Remember, simplifying using addition, you combine like terms. How is that different than subtracting? You have to remember to subtract everything in the parenthesis here. So it'll be minus x and then minus 1. Then combine like terms. Remember that this x is really a 1x, so 2x minus x is x, and then x minus 1. When you have 2x parenthesis x plus 1, this means multiplication. So 2x, x plus 1, we can use the distributive property. 2x times x is 2x squared. 2x times 1 is just 2x. All right, a review from dividing rational functions. Remember that in order to simplify anything, it has to be the same in the numerator and the denominator. I could take a 2 out of the top, but I can't take anything out of the bottom, x plus 1, so nothing simplifies. So that is as far as it goes. So that's the answer. Okay, here we have a power function. We have a quadratic. It has a square is the power. It says to substitute 2x in for y. So we replace the y with the 2x. Now we have a product to a power, so it's going to be 2 squared, then x squared. So you're going to end up with 4x squared plus 1. There. So remember, when you substitute, you replace the variable with this expression. Then remember to distribute the exponent to everything. So what are power functions? Power functions are functions that are the form of ax to the b power, where a is a real number, so no imaginary coefficients. You can have irrational coefficients, but no imaginary. And b is a rational number. Remember, rational numbers are anything that can be written as a fraction. So 5 is rational, 1/2 is rational. Irrational numbers, irrational are like pi is irrational, the square root of 3 is irrational. So anything that's written in this form. So it could be like f of x equals 2x to the third. That's a power function. It's a cubic function, to be specific. 2x to the 1/3. That is a cubed root function, but it's a power function. The power is to the 1/3. All right, domain. Usually all real numbers, not always though. Remember that the domain is all possible input values or all possible x's. Okay, so what are the x's that you can plug in? What are all the possible x's that you can plug in? Those are your set of domains. Here's a couple restrictions that we have. There's no negative allowed under the radical when the index is even, because we want real number coefficients. We want no imaginaries, remember? So if it's a even, like a square root or a fourth root, you have to have positive numbers under here, because if you had a negative, it would be imaginary. So no negatives under the square roots of any even index. Remember, the index is the little number there. And then you can't have any zeros in the denominator. That refers to mostly like the domain. If you have x over x minus 3, then this function would be undefined where x equals 3. So this function, x can't equal 3 because you can't get a 0 in your denominator. So that's what that restriction applies to. So these are mostly review. We've talked a lot about this stuff before. All right, so if I have two power functions here, f of x is equal to 3x to the 1/3, and g of x is equal to 2x to the 1/3. First part tells me to find the addition of those two functions. So 3 is f of x to the 1/3 plus 2x to the 1/3. Now remember, whoops, when we add with rational functions or rational expressions, if this is the same, then you just add or subtract the coefficients. So since they're both x to the 1/3, 3 plus 2 is 5. And then the rest stays the same, 5x to the 1/3. Now when it is a fractional exponent, sometimes it's hard to think about domain because you're wondering what are all the possible x's that you could plug in. And might help to think of it as a root. So remember that this would be the same thing as 5 and the cubed root of x. Now, can you take the cubed root of 8? Sure, you get 2. Can you take the cubed root of -8? Sure, you get -2. I could do the cubed root of 8,000. I could do the cubed root of -8,000. Could I do the cubed root of 1/8? Sure, I'd get 1 over 2. So I could take the cubed root of any real number, including positives and negatives and everything. And so since I can plug in anything I want into there, it's all real numbers. So remember, formally that'd be written as x is an element of the real numbers. And you could also just say, my domain's all real numbers. Could write in a set notation, all x's from infinity to negative infinity. Okay, this is the one I prefer. Scroll back up a little bit here. Maybe it'll let me, there we go. If we're subtracting them, instead, this time you'd subtract the coefficients and get 1x to the 1/3, which would just be the cubed root of x then. Same argument over here, you can take the cubed root of any x, so x is an element of the real numbers is your domain. All real numbers. All real numbers is my domain. All right, they want me to do a few different things here with these power functions. So f of x this time is 4x to the 1/3. G of x is x to the 1/2. So 4x to the 1/3 times x to the 1/2. So we're multiplying. So first we're going to multiply the coefficients. Remember, this is like a 1 here. So 4 times 1 is 4. And then when we're multiplying with variables, the bases are the same. And then you add the exponents. So we're going to have, 1/3 x to the 1/3 plus 1/2. I'm going to do a little side work then over here. 1/3 plus 1/2. I need a common denominator. I'm going to use 6. So I'm going to change this one to 6 by multiplying it by 2. So 2/6. 1/2 is the same thing as 3/6 if I multiply both the top and bottom by 3. And then 2/6 plus 3/6 is 5/6. So 4x to the 5/6. Now if I'm thinking domain, again I want to think about maybe in root form instead. So this is going to be 4 the 6th root of x to the 5th power. So I have an even root. Now an even root means I can't have anything negative under my radical. So I can't have x to the 5th can't be negative. Now think if you took a negative number to a 5th power, like if you did negative 2 to the 5th power, that would still be negative 32. So since if you take a negative 2 to a 5th power, your answer is negative, and you can't take an even root of a negative number, and so you can't plug in any negative numbers in here. So it's an even root, you can't have negatives under there. So the domain has to be x is greater than or equal to 0. You can plug in 0, take the 6th root of 0 and get 0. You can't take the 6th root of a negative number. So that's your domain. If this would have been 4 6th roots of x squared, the domain would have been all real numbers. The reasoning behind that is because x squared is on the inside. Any number that you square is ends up being a positive number. So the 6th root of a positive number is just fine. So that's the difference there. All right, part B, we're dividing the two. So 4x to the 1/3 divided by x to the 1/2. So here I need to use my quotient rule. First, 4 divided by 1 is 4. Then x, we're going to do, the quotient rule says you subtract the exponent. So 1/3 minus 1/2. Remember that 1/3 was 2/6 and 1/2 was 3/6. So I'm going to end up with negative 1/6. This is going to be 4x to the negative 1/6. I can't leave it as a negative exponent, so I'm going to have to do 4 over x to the positive 1/6. To the positive 1/6. Now technically, this is the same thing as 4 over the 6th root of x. Now if you want to simplify this the correct way, you can't leave the radical down here, so you have to take it by the 6th root of something. I'm going to need, I have 1x here, I'm going to need 6 x's to cancel out this root. So I have 1, I'm going to need 5 more. I'm going to need 5 more here as well. So my final answer is going to be 4 6th roots of x to the 5th. And down here, the roots are going to cancel, and I'm just going to get x to the 6th. So this would be the simplified answer. I think we're willing to accept this here as well. We're definitely going to use this top one to look at domain. You have the 6th root of x down here. Remember, if it's an even root, you can't have negatives. You also can't have 0 in the denominator. So 0 can't be in the denominator, and you can't have anything negative. So this one would be x greater than 0. Can't have negatives, can't have 0. Can't divide by 0, and you can't have any negative numbers. So that domain is x is greater than 0 instead. This is in simplified rational form of that. All right, some good old linear function review. F of x times g of x. So f of x is x plus 4 times g of x is x minus 7. So here you can use FOIL or box since it's a 2 by 2. So if you FOIL, it's first x squared, outside negative 7x, inside plus 4x, last negative 28. Then you combine like terms. So x squared, negative 7 plus 4 is negative 3x minus 28. Now you'd get the same thing if you did it in the box. X and 4, x and negative 7, you get x squared, negative 7x, 4x, and negative 28. So you get the same answer here. All right, think about domain. Can you plug in any x you want? Could you take negative 1,000, square it, minus 3 times negative 1,000, minus 28. Sure, you get an answer. What if you had like pi squared minus 3 times pi minus 28? Sure, you'd get an answer. It wouldn't be rational, but you get an answer. So you can square any number you want, take it times 3, subtract 28 from it. So this one is all real numbers. X is an element of the real numbers. Remember, it can't have negatives under an even root, and you can't have 0 in the denominator. Those are the only two things that you need to check for. Otherwise, it's all real numbers. So f of x over g of x, you're going to have x plus 4 over x minus 7. Now look at the top. X plus 4. Can you take anything out of that? Nope. So it stays x plus 4. Can you take anything out of the bottom? X and 7 have nothing in common. So since the 4 is attached to the x on the top and the 7 is attached to the x on the bottom, this can't be simplified anymore. That is your answer. Now in this one, the two restrictions is no 0 or no negatives under an even root. We don't have any roots, so don't worry about that. The other restriction is you can't have 0 in the denominator. So that means that this denominator cannot equal 0. So if you think about what would make that denominator 0, would be 7, positive 7. So your domain is all x's, an element of the real number, except for that x cannot equal 7. So all real numbers except for 7. 7 is the only number that you cannot plug in. Every other number is fine. All right, last example. F of x times g of x, 5x to the 4/3 times x to the 1/3. So you're multiplying, so you multiply the coefficients. 5 times 1 is 5. And then when you have bases are the same and you're multiplying, you add the exponents. So 4 plus 1 is 5/3. That's nice that this is a simplified expression already. Now I have an improper fraction, or these are the same denominator, so I was able to add. I have an improper fraction, which means that this can be simplified when it's in radical notation. This is 5 cubed roots of x to the 5th. X to the 5th. And we got a cubed root, so I can take out 1x. So this would really be 5x cubed roots. There's 2 x's left, so x squared. This would be the simplified expression for that one. So we have a cubed root and an x squared. Cubed roots are fine. You can't have negatives under an even root. Cubed root's an odd root, so that's fine. You're not dividing by anything, so you don't have to worry about the denominator equaling 0. So domain is all real numbers. You can plug in any x you want. Dividing 5x to the 4/3 over x to the 1/3. You divide. 5 divided by 1 is 5. And then when you're dividing and the bases are the same, here you subtract the exponents. 4/3 minus 1/3 is 3/3. Well, 3 over 3 reduces to 1. So it's just 5x. Well, you can take any number you want and multiply it by 5. So the domain is going to be x as an element of the real numbers. It's all real numbers. No even roots, nothing in the denominator, so all real numbers. So it comes back to those two restrictions that you're looking for when you're talking about domain. Domain, think restrictions. No negatives under even roots, so like 2, 4, 6th root, and then you also have no 0 in denominator. Those are your two restrictions for domain. If neither one of those restrictions are in your problem, then it's all real numbers. So if you have one of those, you have to think about it a little bit. Otherwise, it's all real numbers, or x is an element of the real numbers. So Restrictions are important to remember. It's usually all real numbers except for when you have this restrictions. So if you didn't write this down yet, pause this now and write it down. Otherwise, thanks for watching.